This is Mr. Martin. This is the first video for section 3.2 for Geometry Honors. We're going to start looking at how to prove that triangles are congruent. And really important topic for us. If you have any kind of trouble with it at all, make sure that you get help from me or from the point or from one of your friends, but make sure that you get help. So looking back at the definition of congruent triangles, it says if triangles are congruent, then their corresponding parts are congruent. And this actually tells us a lot of stuff, because if we know the triangles are congruent, then we've got 6 pair of parts that are also congruent. So we've got 3 pair of angles and 3 pair of sides. Now the converse of that would say if the corresponding parts of 2 triangles are congruent, so the corresponding parts being the 3 sides and the 3 pairs of angles are congruent, then the triangles are congruent. So we talked a little bit in class how this would imply that in order to get the triangles congruent, you would need to get all 3 pair of sides and all 3 pair of angles congruent first. And that's a lot of information. That would be 6 pieces of information for every proof that you needed to prove triangles congruent. So fortunately, that's not the case. Fortunately, we only need 3 pieces of information. So basically, the 3 pieces of information are going to guarantee that our triangles are congruent. So let's take a look at the first postulate for proving triangles congruent, side, side, side. When you use this in proofs, you'll just write SSS, and then you're going to put some numbers in parentheses, but we'll talk about that later. So it says, if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. So if I had each of you cut 3 sticks, let's say they were 4 centimeters, 5 centimeters, and 6 centimeters, and put them together to make a triangle, so I fixed the lengths of the sides, all of your triangles would be exactly the same. All of your triangles would be congruent. So this postulate here guarantees our triangles will be congruent. So 3 sides of my triangle congruent to the 3 sides of your triangle, our triangles would be congruent. So the 2 other methods that we're going to look at, there's going to be a few more methods coming up soon, is side angle side. So if 2 sides and an included angle, remember we talked about included in class, and I made a big deal about that because it's really important. So 2 sides and an included angle, the angle in between those 2 sides of one triangle, are congruent to the corresponding parts of another triangle, then the triangles are congruent. So again, another method using 3 pieces of information, not all 6, to get that the triangles are congruent. And again, in your proofs, you're just going to write SAS, and then in parentheses, you're going to put some numbers. And then the third method that we're going to talk about here is angle side angle. So if 2 angles and an included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So again, here's that idea of included side. Very important. It's got to be the side in between the 2 angles. Then we can guarantee the triangles are congruent. In our proofs, we'll just put ASA, and in parentheses, we'll put some numbers. And again, we'll talk more about that. So go ahead and move on to video 2. We'll look at some very basic examples, just looking at tick marks to decide if, based on what's given in the picture, we can prove the triangle's congruent, and if we can, which method we can use.